Hello, welcome to my presentation video on measurement. My name is Martin Lavachka, and in this video I'm going to talk about measurement applications, description of applications, and IEC 61557-12 standard. Measurement applications. This chapter is an introduction to the different applications of measurements and the main standards relevant to these different applications. There are different kinds of applications that need measurement. Basically, applications can be split between 5 categories, as described in figure S1. Measurement applications. Energy efficiency and cost savings. For this application, an energy needs to be measured to make it more efficient to allocate it within a plant or to reduce its cost. The main standards are specified in figure S2. Power availability and reliability. To operate an electrical installation, it is recommended that measurement of the main characteristics of the supply, such as voltage, current, frequency, and active power, are provided as a minimum. Some electrical phenomena can have an impact on both installation assets and operation within a plant. The following table describes the main problems that can occur in a network and their potential consequences. The main standards for power availability and reliability are specified in figure S5. Grid power quality. Some regulations or specific contracts require energy providers to keep voltage characteristics at any supply terminal within specified limits. These specifications cover limits or values related to voltage, frequency, rapid voltage changes, harmonics, interharmonics, imbalance, dips, swells, interruptions, flicker, etc. Measurements are typically made on the energy provider side and on the consumer side with power quality instruments class A according to IEC 61000-4-30. Standards for grid power quality assessment are specified in figure S7. Billing. Billing is the process that allows energy suppliers or their representatives to invoice their customers according to a defined contract for measured usages or services. These applications are covered by international, regional, or local standards in addition to utility specifications. Devices for billing applications are devices with specific legal metrology requirements and are the subject to specific requirements such as periodic verification according to local regulations. cost allocation, bill checking, and sub-billing. Sub-billing is the process that allows a landlord, property management firm, condominium association, homeowner association, or other multi-tenant property to spread out an invoice over tenants for measured usages or services. This fee is usually combined with other fees within a tenant's facility fee. Since the meter used for sub-billing is typically installed in an electrical room not accessible by the tenant, the risk of fraud is very limited. This is why devices complying with IEC 61557-12 as well as devices used for billing applications can be used for sub-billing applications. Attention should be put on environmental aspects where the device used for sub-billing needs to fit EMC, temperature, and mechanical environment. In any case, measuring devices used for sub-billing in switchboards and panels need to comply with IEC 61557-12. Cost allocation is the process that allows a facility manager to allocate energy costs to internal cost centers that consume energy. Bill checking is the process that allows customers to check invoices sent by energy suppliers or their representatives are correct. Increasingly, digital equipment is replacing analog equipment in electrical installations. It supports more accurate measurements of new values and can make this available to users at both local and remote locations. Devices intended to perform monitoring have various characteristics which require a shared reference system. This system must allow users to make easier choices in terms of performance levels and dependability and to interpret different measured parameters. All these various measuring devices have to meet the requirements of International Standard IEC 61557-12 Part 12. The standard gives a list of the main requirements applicable to PMD with guidance about sensors to use. All the possible electrical parameters to be measured are listed. For each parameter, a list of requirements is specified, such as the rated range of operation, the range of influence quantities, the measurement techniques, etc. The considered electrical parameters are active energy, reactive energy, apparent energy, active, reactive, and apparent power, frequency, RMS phase and neutral current, RMS voltage, power factor, voltage dip and swell, voltage interruption, voltage unbalance, harmonic voltage and distortion, harmonic current and distortion, and maximum, minimum, peak, average, and demand and values. According to this standard, devices have a code denoting their installation options, operating temperature range, and accuracy class. As a result, it has become significantly easier to select and identify these devices. Figure S9 demonstrates identifying measuring devices in accordance with IEC 61557-12. The notion of performance classes specified by IEC 61557-12 is much more than a requirement related to uncertainty and nominal current. It is also intrinsic uncertainty, operating uncertainty, and overall system uncertainty. Intrinsic uncertainty is the uncertainty of a measuring instrument when used under reference conditions for different power factor values. In this standard, it is a percentage of the measured value. Figure S10 specifies intrinsic uncertainty limits for class 1 and class 0.2 active energy measurement at power factor equal to 1, according to Table 8 of IEC 61557-12. Figure S11 specifies intrinsic uncertainty limits for class 1 and class 0.2 active energy measurement at power factor equal to 0.5 inductive and 0.8 capacitive. IEC 61557-12 also specifies requirements about no load conditions and starting current. Operating uncertainty is the uncertainty under the rated operation conditions. IEC 61557-12 specifies tests and uncertainty maximum variations of uncertainty due to various influence quantities such as ambient, frequency, unbalance, harmonics, and EMC. We come to the end of this presentation. Thanks for watching.